Recording is rolling. It is Thursday, March 19th. Last Aleks day before spring break. Hit 110 from last week. Still open. 310 we're doing this week is open. And I'm gonna solve a couple with you guys because yeah, these we're getting close to the end of the book now. So these questions get a little trickier. You can also take this opportunity to work on your 90% final, which is due in a couple of months. Right? You can do quiz corrections if you like. Pass all the papers back tomorrow. Tomorrow we're going to do a game theory activity. Right. So I think the couple from your Aleks want to cover with you guys. Okay. Let's start. Just these last two right here. All right. Let's go. Very last one, number 19. All right, here I'll show you this one, then we'll try a different one. All right, so we got a dartboard with the numbers 1 through 6. Right. Okay, we got some slices, a couple slices that are gray, and some slices that are white. Right. So it says the dart will be tossed, land on a slice at random. What's the probability that lands on a white slice? Well, there are 4 white out of 6 total, so 4 out of 6, and you can reduce that to 2 out of 3. So it did take the correct answer. And then there was a conditional question, conditional probability. What's the probability the dart lands on a white slice given that the dart lands on a number less than 5? You guys see that phrase right there? Given that, right? Given that something something, right? So we're going to start with the given. All right, so number less than 5. Guys, if you look at the dartboard, how many numbers are less than 5? Yeah, there are 4. There's 1, 2, 3, 4. Right. So we're going to narrow it down. We're going to throw out the 5 and the 6 as if they don't even exist at all. We're going to say out of the 4 remaining slices, 1, 2, 3, 4, what's the probability that it's white? Well, isn't it these 2 out of 4 total? Because we throw out the 5 and the 6. So it's 2 out of 4. We're just reduced to 1 over 2. Okay. So let me try another one here. Okay. Now we got cards. We got 5 white cards and 3 gray cards. It looks like. All right. Card will be drawn at random. What's the probability that the card is white? Guys, what do you think? Probability it's white.
5 out of 8.
Yeah, 5 out of 8, and that's already reduced. So we'll go with that. What's the probability the card drawn is white? Given that, so now we've got conditional probability, the number drawn is less than 7. So which cards are we going to throw out? The 7 and 8. They don't even exist anymore. So maybe somebody says, oh, yeah, I drew one, and, well, it was definitely less than 7, so that's what I'm going to... Right. So out of the remaining 6 cards, what number do you think I should type right here? Yeah, 4 out of 6, which does reduce to 2 out of 3. Yeah, no, just to be safe, I'll put in the reduced fraction. Right, so 2 because it is 4 out of 6, right? Is there any question about that? Let's double check, make sure it gives it to us. Should, yeah, it likes that.
What's my grades?
All right. All right. One more I want to do with you guys here. All right, so here's one. Guys, this one's a little trickier. Number 18. There are 4 women, 5 men chosen for a game with a chance to be on the game show. The producer's going to choose 5 of these people at random. What's the probability that he ends up choosing 2 women and 3 men? Now, the way I'm going to do this is, let's see, there are, I'm writing this on paper, off screen, I'm going to switch over. 4 women, 5 men, for 9 total. Okay, this is people who want to qualify. And we want the probability of 2 women and 3 men. All right, so let me switch my screen over and show you guys how I solved that. Right, so here's the candidates. These are my candidates. That's right here. Okay. So 2 women and 3 men. So I think that the way I do this, guys, if you see a probability, I think a lot of these probabilities for fractions, so I'm going to set up a fraction. You guys see I'm setting up a fraction here? I'll say probability of that outcome equals something. Now, there are 9 total participants. So how many different ways could I choose? 5 out of the 9. Guys, how many? Guys, just a few minutes here. I'm trying to help you guys out. This is a little tougher one. How do I do the math to say there are 9 total candidates and I need to choose 5? How do I do 9 choose 5? Is that 9 choose 5? Right. And remember, there's the margin here. If you have some number and you're choosing among those, like NCR, right? This is for combinations. Combinations. Okay. This is in contrast to permutations. No, say I don't care about the order. I don't care about like who's standing on the left of the stage and who's in the center and who's in the right. I don't care about the order of the people. I just that's why I'm doing combinations instead of permutations. This right here is equal to.
Do about it.
See, it's n factorial over n minus r factorial and then r factorial. Right, guess and if it was permutations, you get rid of this. So there's great varied number. Right, so out of out of 9 candidates, there's and you're going to choose 5. There's this many ways to choose that. Right? And just to show you guys what that number is, in this case, it would be 9 factorial over. Guess what's 9 minus 5? 4. So 4 factorial and then 5 factorial. Okay, let's see what could that be? Like how many different ways could you choose among these 9 candidates? Right, so 9 factorial divided by, and then parentheses 4 factorial 5 factorial. Okay, that looks like 126. There are 126 different ways to choose. Right, or I could have done this way. Say I type 9, place this in, then go to probability, do NCR, and then 5, and oh look, it's also 126. There you go. I just showed you guys a few different ways to get to the number 126. Okay. That's taking the place of this denominator right here. But what about the numerator? I still haven't addressed 2 women and 3 men specifically. Okay. Well, I can do a similar thought process up here. So out of 4 women, I want to choose 2 for this particular scenario. So that's 4, choose 2. And out of the 5 men candidates, I want to choose 3. So that's 5, choose 3. And then I can simply multiply it. Right. So and you could do the same math process and get how many combinations of women and men, blah, blah, blah. Right. Let's put it on the calculator all in go. So we're going to do 4 NCR2, put that in parentheses, multiplied by 5 NCR3, right? It's like 5 choose 3. Then divide by, and then, well, I know what 9 choose 5 is, it's 126, but just for completion, I'll go ahead and type it in that way anyway. Okay. So I'm getting this decimal right here, 0.476 something, 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 right? Which you can interpret as 47.6%, which I think also kind of makes sense because pretty close to 50% split, but there's a little bit more men and we want to choose a little bit more. Okay, so I think the plurality of the time, that's probably what's going to happen anyway. Okay? And go back over to Aleks, and that's exactly the answer they were looking for. That's it. All right, so let's do this. Let's try another, and it should give us a pretty similar scenario. Jenny's bucket, there are 8 brown worms and 10 red worms. Jenny's going to choose 11 worms at random to use for fishing. What's the probability that she ends up choosing 6 brown and 5 red? All right, round your answer to 3 decimal places. Okay. So here, I'm going to, same as before, I'm going to write those numbers on here. We've got 8 brown. We got 10 red, right, for 18 total. 18 total. I'll say this is like, well, I got candidate worms. Candidates. Then, okay, just going to choose 11. What's the probability of choosing 6? So probability of 6 brown and 5 red. All right. So switch my screen over. Yeah, this is pretty similar to the other scenario we just saw. So what's this probability? Okay. So I'd say the probability is, okay, again, instead of a fraction. Okay. Well, we're choosing 11 total out of the 18 total. So it's 18 choose 11. Right. So with combinations. So I'll do that. And out of the 8 brown, what's the chance that she picks 6 of those? So 8 choose 6. Okay. And out of the 10 red that she chooses 5 of those. So it's 10 choose 5. And I can simply multiply those together, just like I did the last one. Okay. Now, of course, you guys know what combinations math is. That's exactly this right here. So like that. So let's try it right here. So I'll do 8 choose 6 times 10 choose 5, and then divide by, and open parenthesis, 18 choose 11. Okay. And that's telling me 0.2217 or 22.17%. Now they might want you to round to 3 decimal places, so it's probably 0.222. So let me see if that's what they were looking for. Yeah, 3 decimal places. let's go 0.222. That should be the answer. And I think that makes sense too. Yeah, about 20 something percent. That seems reasonable. Right? Yeah, that's it. All right, so there you go. I did a couple with you guys. Guys, make good use of your time. And all right, and here's what we're doing.